Alright, welcome to my YouTube channel. This is Bruce Tutor, and what I do here is solve technical drawing problems, and I also provide very important information that you can make use of for you to have a better performance in your technical drawing examinations. And if you're a technical drawing student, I want to ask that you subscribe to this YouTube channel, put on the notification bell so that whenever I upload a new video, you'll be notified, and also help me to share my videos with your friends who are technical drawing students. And do not forget to practice. This is a practical subject. It's very important that you practice so that you can master it, and that will enable you to be able to solve any question that comes your way when it comes to technical drawing. So right now, I want to solve this problem. I have actually, this is 2021 GCE question on mechanical drawing, and what I'm trying to do here is to make you understand what you are going to get based on the main questions given, which I'm going to show you. But what I'm doing here is that I want to I've made the isometric view of this part. So as we have here, let me read the instruction as given here, that figure 3 shows the part of a machine bracket in first angle orthographic projection. Part A slides on part B until face C of part A flushes with face D of part B. Okay, what they are saying here is that this orthographic views that we have here, as we have here, this is the front elevation and this is the end elevation. This is for one component, so which they call part A, and what we have here as part B, this is the front elevation and this is the end elevation. This is another component. So if we put this component together and we form an isometric view of this object, and we also form isometric view of this object, which is part B. So we are going to put this one, we put it here on this part B, and it will be sliding. So part A will be sliding on part B. So as we have here, this is this point here, or this outline here, is face C, and this outline here is face D. So by the time this part A is sliding on part B, face C will rest on this face D. That is what the question is telling us. So I've made the isometric view of part A already, so I want to make the isometric view of part B. And by the time we do that, when it comes to mechanical drawing, it's very important that you are able to visualize the assembling of the object. And let me show you the question that we have here. As we have here, that draw full size in first angle orthographic projection the assembled bracket showing the question A sectional front elevation on plane KK, and B plan, and C we have right end elevation. We are asked to show the hidden details. Now by the time I produce the isometric views of these two objects, then we'll go on and answer the given questions. That means we'll be answering question A, question B, and question C by the time we look at the way they will be when we assemble the two parts or the two components. Okay, so right now, as I said, I'll be making the isometric view of part B, but let me show you, or let me explain the dimensions as we have here. Let me start with the front elevation. So we have that the distance from here to here is 140 millimeters. Then distance from the center of this hole to this end is 40 millimeters. Distance from the center of this hole to this end is 20 millimeters. Distance from here to here is 37 millimeters. And then we have that the distance from here to here is 20 millimeters, and the length of this cylindrical part is 95 millimeters. Here we have 4 holes, 10 diameter 10 counterbore, and then we have diameter 16 by 5 millimeters deep. So, and let's come to the end elevation. So in the end elevation, we have that we have this. So distance from here to here is 125 millimeters, and the length distance from here to here is 90 millimeters. And then we have the distance of this hole from this end here is 12 millimeters. So the same thing applies to this. Distance from here to here is 25 millimeters, and then the distance from here to here is 75 millimeters, and then we have distance from here to here to 40 millimeters. And then this non-isometric line is inclined at an angle 60 degrees to the horizontal. The diameter of this hole is 24 millimeters. So we are going to make use of all these dimensions for us to produce the isometric view of this object. So that will help us to be able to answer question A, question B, and question C as we are given there. So let's start. So the first thing that we are going to do here, okay, let me show you the first thing that we are going to do. We want to draw this L part. This L part. By the time we are able to produce this L part, this part will come out. This rectangle that we have here, so the whole of this rectangle length 125 and with 90 millimeters will come out. Then be able to put the rest of the features that we have here. Now, as I said, so we start by drawing a horizontal line. So I believe you can see this horizontal line that I drew. Then we take our set square. So we take our set square and we draw a line in this direction. The set square I'm using is 30 by 60 degrees set square, and then we also draw a line from this point. So we draw a line in this direction. Okay, so now, so what I'm going to do now is that I will also draw a vertical line at this point here. So don't forget that normally if it's an isometric drawing that we are asked to produce, so they will give us lowest point A or lowest point X, but that is not said here. So this is the lowest point now in my drawing. So I'll take a measurement here. So a measurement of 140 millimeters, as I've shown you in the main question, that the length on this side is 140, and then on this side I will take 90 millimeters. So this is 90 millimeters. So at each of these points, I'm going to draw a vertical line on each of these points. So we draw a vertical line here. So just a short vertical line that can be up to 137 millimeters. And here I will draw a long vertical line that will give me a measurement of 125 millimeters. Okay. All right. So I may need to increase this a bit. All right. Okay. Now, so with what I've done here, so the first thing I'm going to do is that I will take a measurement of 25 millimeters. 25 millimeters. So this is 25 millimeters here. So with this 25 millimeters that I've taken, I'm going to transfer it to this side. So I will transfer this 25 millimeters to this side. Okay. All right. So, and I will also take it backward a bit. So it goes like this. Okay. Then I will take a measurement of 125 millimeters. 125 millimeters. So this is 125 millimeters here. All right. So at this point, I will draw a line in this direction. So you should know that this is going to take time. So we just have to exercise patience. So we have to exercise patience. So, and then I will take a measurement of 20 millimeters as we have in the question. I'm going to take this down as a vertical line. So here I will draw a vertical line here like this. Then here I'm going to transfer this point. I'll transfer it to this side. Okay, so I transfer it here, and then this 25 that we have here, I'm going to take it. So I'll take it backward like this. Okay, then here I'm going to draw a vertical line at this point. So draw a vertical line here. Then I'm going to transfer. So I'm going to transfer this point. Okay, so I'll transfer this point. So I transfer it to this line. Then this also, I will transfer it backward like this. Then from this point here, I'm going to draw a line. So transfer this point backward. Okay, so I believe you can see what we have formed now. So the next thing that I'm going to do is that, so let me show you what we have done so far. So what we have done here is that we have produced this L part, this L shape here. We have produced it, and then we have formed this rectangle here, including this is supposed to be a rectangle, so with 25 millimeters. So that is what I've done here. That's the rectangle that we have here. So then this, if you look at this, the distance from here to here is 137. So this rectangle that we have here is part of this shape that we have up here. So I've not done that. So the next thing that I'm going to do is to draw this cylindrical part. This cylindrical part, I'm going to draw it on this face here, is on this face, as we have the circle here. So this is the end elevation of this cylindrical part. So so what I'm going to do now is that, so what is the distance from this point to this point? It is 94 millimeters. So if I divide 94 by 2, so that will give me 47. So that's 47 millimeters. So I'll just take 47 here. So this is okay, so this is 47 millimeters. So I'm going to transfer this point to locate the center of this part as we have in the question. So let me show you the question first before I so that so as we have in the question here, so we have that the distance from here, from this point here to the center line is 75 millimeters. Maybe I should just take it like this. So I just take 75, so that we take 75 from here. So from this point, I will take 75 millimeters. So this is 75 millimeters. So all I need to do, I think it's going to be at the same point. So so it's 75 millimeters. Okay. So all I need to do here is to transfer so this point. So I transfer it here like this, and then so I will now take it. Okay, that's almost at the same point. Okay, so I'll take it and take it to this side. All right, so we have that. Then this 90, I'll divide it into 2. That is 45 millimeters. So this is 45 millimeters. So I will draw a vertical line on this face here. So draw a vertical line, a vertical center line here. Even that line is supposed to be a center line. Okay, so now, so I'm going to draw. So don't forget that the diameter of the circle, as we are given in the question, is 20 millimeters. So diameter of this circle here is 20 millimeters. So I'm going to take a measurement of 12 millimeters to the right side and 12 millimeters to the left side. So this is it. So just take it easy. So this is 12 millimeters to the left and 12 millimeters to the right side. Then so I will take 12 millimeters up and down. So 12 millimeters. So this is 12 millimeters down here and 12 millimeters up. Okay, so I will form a square. I'm going to form a square here on this face. So this is it. Okay, so coming up here, so I'll draw this line, and here I will draw a vertical line. So this is a vertical line here, and here also I will draw a vertical line. All right, so I formed the square. So this square that I formed, I'm going to transfer these points. So I will draw a line in this direction. You have to draw it, and here also at this point I will draw a line in this direction. So I will come up here, so I will draw a line, so it go forward like this, and here also I will draw a line here. Okay, so what I've done here now, so the length of the cylindrical part is 95 millimeters. It's 95 millimeters. So let me check it. So this is it. So we have it as 95 millimeters from here to here. 95 millimeters. So I'm going to take a measurement of 95 millimeters from this point. So this is 95 millimeters. So I'm going to transfer this. So I'll transfer this to this point. Then I will take this down. So I take it down like this. I want to form a square on this face. So I will also take this. Okay. So let me transfer this first. So take it down, then here. So I'll draw a vertical line here. All right, so I formed the square on this face too. So right now, so I'm going to so let me transfer this point. So this midpoint here, so I need to transfer it to this place. Okay, then I'll transfer this to the other side. Okay, then so I will divide this 24 into 2. So this is 12. Then here I will draw a vertical line. All right, so the next thing I'm going to do is that I will join this together. So join this together like this. Then I will connect this to this point. So I believe that you know how to draw isometric circle, because that is what I want to do here. So I believe you know how to do that. So I'm going to draw the isometric circle, then I will come and show you how we can form the cylindrical part. All right, I've drawn the isometric circle as you see here, and here we are not to draw the whole of the circle, so you only need to produce a little part of that. Is I think this half, yeah, this half of it, so just produce half of it. Then we are going to form the cylindrical part like this. So all you need to do is to take your 30-degree set square, so you set at this point and you join these together. So you join this point together like this. So draw a line from here to here, and then you come down here. So come down here like this, and you join. So join this together with a straight line. All right, so we have formed the cylindrical part, but I want to bring out what we have here already. I want to bring it out. All right, the next thing I'm going to do here is that I want to draw this shape. I want to draw it so around here. So for me to do that, first of all, I will need to, okay, I've already divided this 90 into 2. So I will transfer it as a center line. So I will transfer it down to this point here. So this is okay. So now, so with what I've done now, so as we have that the middle one is 40, so I will take a measurement of 25 from this point to this point 25 millimeters, and from here I will also take 25 millimeters. So this is 25 like this. So I'm going to transfer. I will draw a line. So from here, so draw a line from here down to this point. So I will also draw a line. So from here, so I'll draw a line from here. All right, so this is the line. Okay, then I'm going to erect a vertical line. Here we erect a vertical line at this point. So here I will also draw a vertical line at this point. Then I will take a measurement of 12 millimeters. So as we have in the question, so if you look at what we have here, we have 37 millimeters at this point. So if I remove 25 from 37, that will be 12 millimeters. So I'm going to take a measurement of 12 millimeters here. So this is 12 millimeters. Then I will transfer this 12 millimeters to this side. Okay, so don't forget that this non-isometric line that we have here in the end elevation, this line is inclined at an angle 60 degrees to the horizontal. So I'm going to take my protractor. So I will set it at this point. So set it at this point. So I will set it like this. Then I will take 60 degrees. So this is 60 degrees. So this is 60 degrees. So the line, so this line that I drew here is it has given us that 60. So we have this point. So then, so how can I get this one? What I will do is that I'll just put my pinpoint on my compass here, extend it to this point. Then I'll bring it here, and I will make an arc on this line. So I'll just join this together. So let me bring out the shape so that we can see how it actually looks. Okay, so I draw. So from here to here, then I will draw this from here to here, like this. So now I can draw this line from here to here, and I can draw this line from here to here, and this line, okay, so this line, so this line from here, so it goes like this. Okay, all right, so then so this line I will still need to extend this line. So this goes like this. All right, so so from this point, so I'm going to take that same 60 degree. So here I'm going to take a measurement of 120 millimeters. So I'll take a measurement of 120. So this is 120 millimeters here. So this 120 that I've taken, so I'm going to transfer this point. So I'll just draw it with thick continuous line at once. So it goes like this. So it goes in here like this. Okay, so this line now, so I'm going to make this line, I'll make it a thick line. Make it a thick line like this. Okay, then this line will be a thick line. All right, so so this is what we have here. So as the shape that we have here on top of this base here. So Alright, next thing that I'm going to do here is that I want to put these holes. So we have these holes. So we have 4 of them, as we are told here that 4 holes, diameter 10, counterbore, 16, the diameter 16 by 5 millimeters deep. So 4 holes, diameter 10, they are talking about this one, and counterbore, diameter 16, 5 millimeters deep. That the diameter of this hole here is 16 millimeters, and the depth from here to here is 5 millimeters. That's what they are telling us, from here to here is 5 millimeters. So we are going to produce that here. And if you look at what we have here, so from this end to this center line here for this hole, it is 40 millimeters, and from here to here it is 20 millimeters. But in the end elevation, as we have that from here to here is 12 millimeters. It's 12 millimeters. From this end to this center line is 12 millimeters. The same thing applies to this. So what I'm going to do now is that I'm going to take a measurement of 40 millimeters from the back here. So 40 millimeters from here, this is 40 millimeters, and then I will take 20 millimeters to this point. Then I will take 12 millimeters. So 12 millimeters here. So the holes that we have on this side, we can't see them because this thing has covered them. So we only need to produce this one. So because this is the only part that we see, this part here, it has been covered by this this part that we place on the top of this base. So now, so what I'm going to do now is that I will draw a vertical center line here. Then I will transfer it to the back. Okay, I transfer it to the back like this. Okay, all right, so then I'm going to draw a vertical line here. Then I will transfer it. So transfer it to this side here. Okay, then I will also draw a vertical line here. So then I will transfer it to this side. So first of all, I will draw the hole for the counterbore. The diameter is 16 millimeters. The diameter is 16 millimeters. So 16 by 2, that is 8 millimeters. So I will take 8 millimeters. So from this point, so here I will take 8 millimeters. So this is 8 millimeters. Then I will take 8 millimeters from here. So this is 8 millimeters here. All right, so, and then I will take 8 millimeters. So 8 millimeters from, so this is 8 millimeters. And then, so on this side, so this is 8 millimeters, that's 16. So here, I just transfer this one here. So I will transfer it down here. I will also transfer this down to this point here. Okay, then I will form a square here, an isometric square. Form an isometric square here. So all right, so I will also come here. So I will take 8 millimeters to this side. So this is 8 millimeters, and I will also take 8 millimeters to this side, so making 16. I will also form isometric square on this face here. Okay, so we are forming the isometric square because we want to produce an isometric circle. So for this, I'm going to join this together. So I'll just join this point together. So I'm going to use my hand to form the isometric circle because this is not really, it's very small. So an isometric circle is an ellipse. So this is how I use my hand to form an isometric circle if the square is small, as we have here. So I will also do the same thing on this side. All right, so we have formed the isometric circle. So the next thing I'm going to do is that we are told that the depth is 5 millimeters. The depth is 5 millimeters. So I'm going to, so from this point, I will draw a vertical line down. And from this point, I will do the same thing. So draw a vertical line down here. Okay, so I will also come to this side and do the same thing. From this point, I will draw a vertical line here. And here also I will draw a vertical line here. All right, so I will now take a measurement of 5 millimeters. So 5 millimeters here. I will take 5 millimeters here also. So 5 millimeters. So I will come in this midpoint here. This midpoint, I will need to draw a vertical line in this midpoint. Very important. I will also do the same thing. So this midpoint, I will draw a vertical line here. So I will take 5 millimeters also on this midpoint line, 5 millimeters here. So, and I will come here also, take a measurement of 5 millimeters down on this mid vertical line, take 5 millimeters down, and then here also I will take 5 millimeters down here. Okay, so these 3 points that I have here, so this point, and this point, I'm going to join them together. So this point, and this point. So I'm going to join them together. I will use a French curve to do that. All right, so I've done one. So the second one, I'm going to show you. Just take your French curve and set it like this. So make sure the points are on the curve. So so you join together like this. All right, so this is how the depth will look. And then we also have a hole that goes down, and as we are told here that the diameter of this hole is 10 millimeters. 10 millimeters. Diameter is 10 millimeters. So I'm going to form a square. So a square around here. So diameter is, so I form a square here. Okay, so I form a square and draw the isometric circle here. So I will do that and I'll come back and show you the final solution. All right, so I formed the holes. So these are the holes. As I said, that it's only the ones on this part that we see, because this part has covered the one on this right side. So what I've done here is that I've produced the isometric view of part B. So as we are given the orthographic views of this in GCE 2021 mechanical drawing. So as I said, I'm trying to let you see the object in isometric form before we assemble, and then we answer the question on sectional view and then the rest of the questions. So we are going to put part A and part B together. As I said, that part A is coming on this, so it will enter this, and then phase C will rest on this phase D. This is phase D to rest here, and then as we are told that part A is sliding on this part B. So all you need to do is to practice. I've done many work on isometric projection, conversion of orthographic views to isometric view. So I've done a lot of work on that. So just practice and you master it. Thank you for watching and thank you for listening. God bless you.